Okay, this problem is actually not very well defined as to what they're trying to achieve, but here's the idea. We've got this rectangle with the area represented by this expression right here, and the width is represented by this expression. And they want us to find the value of b. Well, it turns out there's infinitely many values of b that would allow you to say that the length times the width gives you this expression. Okay, it just depends on what the expression for the length is. So if they had added this caveat that the length must be represented by a polynomial, then that means if this area divided by this width has a remainder of 0, then we could find the value of b that works. Okay, so you can find an expression for the length by dividing the formula for the area, or the expression for the area divided by the width. This is long polynomial division. It gets kind of messy, but here I've said that this is the second term of expression for the length, and when I take that times this width, I get this messy expression down here. And when I subtract this expression from this negative 72, this is the remainder, but I want that remainder to be 0 so that I have a polynomial expression for the length. So if I set that equal to 0 and solve for b, I get a value of 71. And here's the same process using synthetic division. So I'm putting 8 in this box here. The coefficients of x squared x and the constant term are 10, negative b, negative 72. I apply synthetic division. I still get the same expression for the remainder. If I want the remainder to be equal to 0, I'm solving the same equation down here, and b is 71. Okay, so if I go to Desmos, and here's an expression for the area where I have a b for the coefficient of the linear term. There's an expression for the width. The length is L of x divided by equals the area divided by the width. And you can see that when I set x equal to, or b equal to 18, that I get some areas that are integers, because the area function is a polynomial. If I divide by the width is also a polynomial. But the length expression gives me these answers with decimals in them. So that can't be a polynomial if I'm putting an integer into the function for L. But if I move all the way out here to 71 for b, now the area is an integer, the width is an integer, and the length is an integer. By the way, I got to put x values in here that are greater than 8, because otherwise x minus 8 would be a negative number. Okay, so there you go. B has to be 71 with the caveat that the length must be represented by a polynomial. Okay, there you go. Hope that helped. If you have any questions, post a comment.